Hey, so we're looking at another improper rational where we've got a larger degree in our numerator than in denominator. And so what we're looking at here is we would do long division. So when I do the long division, I write my numerator here, my denominator here. Then I ask myself, what can I multiply by this term in order to give me that term? So x is the correct answer, and I write it here. So x, now I multiply this x that I wrote all the way through all of these terms and write the result here. So x times x squared is x to the third. X times negative 6x is a negative 6x squared. X times 10 is a 10x. Then I change the sign. Now, x squared minus x to the, or this is to the third, sorry, x third minus x third. Then I've got a negative 4x squared plus 6x squared gives me a 2. Then I've got negative 2x minus 10. So negative 2 minus 10 is a negative 12x. I drop my 25. Then I ask myself the same question. What do I multiply into this in order to give me this? So the answer is 2. So because 2 times x squared gives me 2x squared. So there's it is. All right, no, and I write it here this time. Okay, always under. Then I multiply it through everywhere. So 2 times negative 6 is a negative 12x. 2 times 10 is a 20. And then I change the sign. 2x squared minus 2x squared, and then negative 12x plus 12x. These guys actually cancel out, so that's nice. It eliminates a stage to this thing here. And let's see, what else do we have? 25 minus 20 gives me a 5. So my remainder is 5. Here's my quotient up here. And so now I go back over here, and the x plus 2 gets written down, plus the remainder over the old denominator over here, okay? And now I've got basically three integrals: the integral of x, the integral of 2, and the integral of this guy here. And this guy here is going to be a complete the square integral. So I'm going to go ahead and take x squared minus 6x plus 10 and write it as x squared minus 6x plus 9 plus 1. 9 plus 1. Why do I do that one? Because this one's pretty simple, and you can realize that you're going to have a perfect square trinomial right here, okay, which ends up becoming x minus 3 squared, and then your plus 1 kind of hangs out over there. I don't need that square. I don't know why I wrote that. I was kind of thinking of something else, I think, and so there we go. And now I do a u substitution. I'm going to let u equal x minus 3. So there it is. And then du is just dx, because the derivative of x minus 3 is dx, and the derivative of u is du. And so there we have it. I'm able to replace the dx with a du due to this formula. I'm able to replace the x minus 3 with a u due to that formula. And now I've got this. I still have that square there. I don't know what I was doing. Okay. I was thinking of a different trig sub, I think. And then whatever, I factored out my 5. Don't forget that 5 was in the numerator. I factored that guy out. Okay, so notice he's there. And if you notice here, this is just your simple trig tan inverse, right? So there it is, 1 over u squared plus 1 gives me a tan inverse of u, remembering that u is x minus 3. And so therefore, this integral is here. So I've gone ahead and written it here, okay, underneath this guy. The integral of 2 dx is just 2x, and the integral of x dx is this guy, one of your basic integrals from power rules there. Anyway, there's a nice integration by long division.